Hi everyone, my name is Daniel Shih from National Taiwan University. Welcome to my presentation. The title of this paper is CholecSeg8k, a semantic segmentation dataset for laparoscopic cholecystectomy based on Cholec80. This work is done by many of my students at the National Taiwan University. I think most of you know that the correct and sizable dataset is a key component for machine learning. In particular, an open and accurate dataset for medical images actually are barely available. Although there are many research proposing using little data to train machine learning model, but it still requires hundreds, if not tens of thousands, data to train a good model. In this work, we use an open dataset for the cholecystectomy surgeries to label human organ to support machine learning algorithm and release the dataset on cargo under the CC by NC SA 4.0 license. We do not collect our own raw dataset. In fact, we use the open dataset called Cholec80. This dataset is published by CAMMA, Computational Analysis and Modeling of a Medical Activity Research Group. This research group cooperates with the University Hospital of Strasbourg, IHU Strasbourg, and IRCAD to build a dataset. The Cholec80 contains 80 video clips of cholecystectomy surgeries conducted by 13 surgeons. Each video clip records the operation at 25 frames per second and has an annotation for instrument and operation phases. Unfortunately, the human organ in these 80 video clips are not labeled in the dataset. So our work select a few video clips, in total 8,000 pictures from this Cholec80 dataset to label the human organ to support the machine learning training. The size of the dataset in our CholecSeg8k is 3 GB in total. We cherry pick about 100 video clips on cholecystectomy surgeries, and the size of each frame is 854 times 480 pixels. We choose to use the 13 classes as you see on the right-hand side of the presentation, including the background, abdominal wall, liver, fat, grasper, blood, and liver ligaments. In this dataset, every image have 3 label masks. The first one is a color mask. This one can be used to visualize the annotation result. The second one is annotation mask. It's used by the annotation tool to read the outcome, to read the label of this for every pixels. The third one is a watershed mask. This mask will be used as a programming tool to read annotation label for machine learning. Among these 13 classes, we focus on cholecystectomy surgery to recognize liver and gallbladders. Other annotation classes actually are defined for border coverage. For instance, the liver ligament, we do not clearly identify different liver ligament. We just only use one class to refer to coronary ligament, triangular ligament, and so on. Because this data set focus on cholecystectomy surgery, so the class actually are not balanced. For example, the liver class occupy like 30% of the data, and the gallbladder classes only occupy 10%, and abdominal wall classes occupy 30% of the data set. The other occupy only have a very few amount of data. So when one uses this data set to train their machine model, they should be aware of this unbalanced data set. This dataset can be used for many purposes. In particular, in these three examples, we use this dataset to train a semantic segmentation model for human organ. The one showing on the top, we actually train the model to recognize the human organ for semantic segmentation. And the one in the bottom, actually, we use this model to train to recognize liver and the liver ligament to allow us to track and register the three-dimension point cloud data onto the general human model.